In this video, I'm just going to work a set of problems just so you can see how they're done before we move on, to the next set of things. These are just all Ohm's law problems. These are the exact same things we did in the last video, but I thought I'd work 4 of them so you could really see how they work. So the first one, this is number 1. A lamp operating at 120 volts requires 0.83 amps. What is the resistance? So you write down Ohm's law, of course. I have a different color for this. Okay, you wrote down both those formulas, and then you just plug in the things you know. So obviously, it's 120 volts, and that will equal 0.83 amps times a number, which is, the same as 120 volts divided by 0.83 amps, and that will give you a number. And I'm going to use a calculator because that's the way I roll. And then I'll give you 144.5 ohms. When you do little problems like this, they will oftentimes give you way more information than is necessary. They'll give you wattages, and you can of course figure this out with watts, or they'll give you horsepower, they'll give you things. It's important just to write down the formula and plug in the things that are actually in the formula. If you want to find out everything about this circuit, and this circuit will look like this. Little picture for you. It's a lamp. And it could be drawn like this. You might put that in there. As we're doing this, just a little word about little symbols. Okay, this symbol is for a battery. It's a DC power source. It'll be used when they want to symbolize a DC power source, even if it's not really a battery. Each one of these is supposed to symbolize a little cell, and it goes off. This is a lamp, usually. You'll see that symbol in, like, if you do car wiring diagrams. They'll use that symbol for a lamp. This little symbol, a circle with an A in it, is usually for an amp meter. A circle with a V in it is usually for a voltmeter, and they'll usually have a little value next to them. Cool. All right. So, go on to the next problem. I really hope I'm in frame. Gonna check. Okay. A 1,000 watt lamp operates at 120 volts. How much current? This is almost the same problem. So, you write E times I equals P. You can also, and you write E equals I times R. Watt's law, Ohm's law, you're good to go. So what do you know? You've got 1,000 watts. So put 1,000 watts under power. 120 volts. Okay, so 120 volts times I equals 1,000. So divide by both sides by 120. Hopefully that's right. All right. Equals okay. 8.3 amps. You can almost always find like E, I, R, P. We write these differently. I did on the next page. And if you draw this little thing for circuits or parts of circuits, you just figure out every part about them, and it goes on later. You know, you'll find frequency, you'll find different things. But for right now, if you fill out this entire chart, you know everything there is to know, and you'll have the right answer. And if you think you got the wrong answer, if something looks weird, you can plug in the formula again, and see how it goes down. See, in this we got these two values, and then we derive this value, the current value, and we can actually derive the resistance value too. So, and you can just do that the same way. 120 volts equals 8.3 times some number. So 120 divided by 8.3 will give you 14.4 ohms. Sweet. Moving on up. A lot of times you will see the problem drawn like this. I drew it like this on the other page. And it's essentially the same problem. What this shows is this symbol, which means this is a DC power source. It'll have a little plus. The plus is usually the long bar. That's just the way it's supposed to be, I think. I haven't actually ever dealt with DC power sources in real life, so I might have that exactly backwards, because I have it backwards over there. Whatever. Forgive my mistake, it'll be okay. The important thing is this. If you just write this down, you can just fill out the chart really quickly. So, voltage, awesome, 12 volts. Resistance, 120 ohms. And because you have those two things, you can go or 12 over 120 is equal to I. Oh, seriously, buddy? Sorry. Probably could have done that one in my head. Anyway, and because power, your watt value is equal to I times E, all you got to do is put that 0.1 times 12 that'll give you 1.2 watts. Yeah, and that's all there is to do about that. Let's do this last one, and then hopefully my examples. Oh, a little M, a circle with an M. This came right out of a book too. That stands for motor, and motors have a lot of complexity, but a lot of times they'll just use them as a load in these examples. And in DC, it just sees it like resistance. It's great. But don't be confused by that M. It's just the same as a little light symbol, just the same as a little resistor symbol. Oh, resistors. This is a symbol for a resistor. We're going to talk about that in the next video. Just so you know. If you see that, it's just the same as a little light. And everything is a resistor. Everything has resistance. It's like mass. They just exist. Okay. So, you go down here, you have your little table. And they usually don't provide you this little table. Just when you're doing these problems, just write it out. And that way you make sure you have everything. Okay. So, 24 volts. $72 watts. Okay, so for this, you're going to need the power formula. Okay, so you have 72 watts is equal to I. Oh, when I wrote these, I didn't realize they were all amperage problems. Whatever. I'm sure you can see. That's a 24. So, you do one of those, and you will get I is equal to 3 amps. Perfect. If you wanted to fill out your chart, make it totally perfect, you would be write it again. And obviously you can do a bunch of this stuff in your head. You don't have to write the formula down. But as the formulas get bigger, it's a good habit to get into, to write the formula down and then replace the values you know. Because it will get harder. Okay. And that's just a little video, show you how to do everything. If you want to double check this, obviously you just plug these numbers back into the formula. 8 times 3 equals 24. And then 24 times 3, 72. And that should be perfect. Thank you very much. Next video will be adding up resistors, and we'll talk about series and parallel circuits, and it will be great.